Hi everyone, I'm Ananya, and I'm going to be doing Leetcode problems 11, 12, and 13. Usually I would separate these into different videos, but they're very short and simple, so let's do them all in one. Let's start off with problem number 11, container with the most amount of water. In this problem, we're given an integer array height of length n. Our goal here is to find two lines, which when paired together with the x-axis, contain the most amount of water. So let's get started. When we first read this problem, the most intuitive solution that comes to mind is going to be a brute force one, where we basically run through the entire array with two for loops and keep track of the maximum area. However, there is a more efficient solution called two-pointer technique, and it's like a greedy algorithm, so here's how it works. We place two pointers, one at the beginning of the array called left and the other at the end of the array called right. Every step, we calculate the area formed by the two lines pointed to by left and right by doing minimum of height left, height right, times right minus left. The height is the shorter of the two lines, and the width is the distance between them. Also note that left starts out at the very beginning, right starts out at the very end, so the width is maximized to start, and then slowly will shrink. So we're trying to increase the value of height so that we can find the maximum area possible. To maximize the area here, we just move the pointer pointing to the shorter line inward. And this is because the height of the container can only increase if we move past the shorter line. We just repeat this process until the two pointers meet and keep track of the maximum area that we encounter. So let's go ahead and code it up. The first thing we need to do is declare our left and right pointers, so I'm going to go ahead and do that. L is equal to 0, R is equal to height.size minus 1. It starts off at the very right side of the array. Now I'm going to declare my area variable, which I'm going to use to track the greatest area that we encounter over time. Let's begin the two-pointer search. While left pointer is less than right pointer, what we can do is update the area variable to be the maximum of the current area, or minimum of height L, height R, times right minus R minus L. After that, we need to move the left and right pointers, or both of them sometimes. So if height of L is less than height of R, since left is shorter, we can update L++. If, on the other hand, height of L is greater than height of R, then we can update the right variable by doing R minus minus. And don't worry about it going out of bounds here, because we have the condition L is less than R to prevent that from happening. Last thing we need to do is, if they are equal per se, that means that we can update both of them and push L++ and R minus minus, just so that eventually the while loop will end. Now, at the very end, we can just return answer, area. Alright, this should work. Alright, all those cases passed. So we beat 21.97, and we have a time complexity of around O of n. So, perfect. Alright, so let's move on to problem number 12, integer to Roman. In this problem, we're given an integer and we need to convert it to a Roman numeral. They've given us some symbols here, as well as the 4s and 9s that we have to account for, since they don't really match any of these. Oh, at the very end, they've also given us another constraint that the number that they give us is going to be between 1 and 3,999. Let's say we want to convert an integer like 1987 to a Roman numeral equivalent. We have to go digit by digit here. So the first digit we encounter is going to be 1. It's technically 1,000, so it's going to be equal to m. And then 9, which is 900, is going to be equal to cm. 8, which is 80, is going to be equal to 150 and then 3 tens. And then the last digit, 7, is going to be 1, 5, and 2 ones. So it seems like, based on just pre-computing some of these values, we should be able to make any combination of numbers. And I'm thinking that maybe we should pre-compute digits like 1,000, 900, 500, 400, 100, and then 90. Yeah, pretty much any digit that A is given in the problem, or B would not be able to be made based on just rearranging some other combination of those pre-existing digits. For example, 4, you can't make 4 with 4 ones, you have to make 4 with its own different symbol. Let's start off coding. The first thing I'm going to do is I'm going to define my vector of pairs. Let's store it that way. It's going to be between integers and strings. Let's call it mappings, and let's start defining it. So this is going to take some time. Let's start off with 1,000. So 1,000 is going to be equal to m. We also know that, 900 is going to be equal to cm. Whew, okay, that took some time. After this, let's see, we can define our string result, which is equal to an empty string to start. Now, let's write our first loop. So while num is greater than 0, we can continue this process where we, for every single digit, int I equals 0, I less than mappings dot size I plus plus. And we're going from biggest to smallest, so we just subtract the biggest digit that we see. Let's first define two values. The int value is going to be equal to mappings of I dot first, and then string symbol, let's call that mappings of I dot second. After this, while num is greater than or equal to value, num minus equals value, and symbol plus result plus equals the symbol that we use for that digit. Okay, at the very end, I believe we can just return the result. Alright, let's try running this. Hopefully it works. Oh, it should be just pairs. Alright, all these cases passed. Perfect! Let's break this down in simple terms. If we analyze the Roman numeral XLII, which represents the number 42, we can start by looking at each part. The first X we come across is 10, but because the character that follows it is greater than the one we're looking at right now, we can subtract 10 instead of adding it, so our current result variable would be at -10. Next, we reach the character L. L is 50 and there's nothing special about it here, so we can just add it. Now our result variable becomes -10 plus 50 equals 40. Moving on, I equals 1. Since the next I isn't larger, we can just simply add it to get 41. And the last I is also 1, so we add it again, bringing us to 42. The first thing I'm going to do here is declare our unordered map, which essentially just maps the symbols to the values. Let's call this car to int, and let's call it Roman map. This map is going to be a little bit different than the one I created before, because here I'm not going to map any subtractive cases like 4 or 9, because there is a way for me to handle that algorithmically later on. Let's just fill in the table as we go first. So I maps to 1, V maps to 5. This is our unordered map. Let's keep an int result for the number building. And now we can start our for loop. So for int I equals 0, I less than s dot length, I plus plus. Here the key is to notice that whenever you run into a subtractive case, it is going to be the only time where the character that you're at right now is less than the one that follows it. For any other number, you think of 1, 2, 3, 5, 6, 7, 8. All of those characters are going to be represented with either numbers that are matching the previous one or numbers that get smaller over time. In this case, we can just check to see if I plus 1 is less than s dot length. Let's just make sure the next character exists. And let's call this Roman map. And Roman map of s of I is less than Roman map of s of I plus 1. Then we can take result and subtract the current value. Map s of I. The other case is where you just run into a normal character. In that case, you can just append the value that you're currently at Alright, and then at the very end we just return result. Those 3 cases worked. Perfect, so we beat 71.21%, and yeah, that's my solutions for problems 11, 12, 13. See you next time.